Hello, everyone. Today we'll be talking about weather maps and forecasting. The picture here is a weather station in Alaska. On Monday's lecture, we talked about wind and air pressure. We'll summarize that, recap that today, and also talk about fronts and weather station symbols. Wind is the movement of air from places of high pressure to places of low pressure. Wind moves in large masses called air masses. Air masses also move from areas of high pressure to areas of low pressure. These air masses retain the characteristics from where they form. We'll talk more about that in just a minute. Air masses can be described by their moisture content and their temperature. The moisture content, whether or not they form over land or water, will determine how much moisture is in the air. So continental air is dry, it forms over land. Maritime is moist and it forms over water. Temperature, how warm the air is. If it's warm, it's called tropical. If it's cold, it's called polar. And if it's very, very cold, it's called Arctic. The further away from the equator, the closer to the poles, the colder that air will be. The closer to the equator, the warmer that air will be. Okay, so let's talk about what does it mean if it's continental tropical. That means that it's dry and it's warm. Maritime tropical, this will be very humid air. It's moist and warm. Polar would be continental, dry and cool. Maritime polar would be moist and cool or cold. And then continental Arctic is very, very, very cold and dry as well. There is no maritime Arctic because if it's that cold, you don't form there's no evaporation at that point, okay? And these are the symbols that you would have. You have your symbols in your chart. So if you see that on the map. There are fronts that we'd like to talk about today, 4 types: warm, cold, stationary, and occluded. And fronts are just the different boundaries between air masses. Along a front, you have warmer, less dense air is always forced upwards because cold air is more dense. A warm front occurs when warm air slowly moves into an area covered by cooler air. It takes a long time for warm air to displace colder air. It's marked by long and steady periods of rain. And you have red semicircles that indicate that on the map. So this is the symbol for a warm front. The warm front, or the warm air is here. This line is the border between possibly a cold front and a warm front. So when you look at this is your warm air. This will be over here. And the warm air is pushing into the cold front, and it's actually being pushed up and over because it's hard for that warm air to displace that denser cold air. Cold fronts are formed when cold, dense air quickly moves into an area occupied by warm air. They're faster than warm fronts, usually marked by heavy precipitation and thunderstorms for only short periods of time. There are blue triangles, right down there, blue triangles that indicate your cold front. If fronts are not moving towards each other, but alongside each other or past each other, you'll have mild precipitation occur, and this is called a stationary front. And you'll have warm front on one side, cold front on the other side. You can see the arrows are pointing out from that cold front, and the semicircles are pointing out from the warm front. Occluded front. They are cold fronts move faster than warm fronts, and it's when a cold front actively takes over a warm front. It'll force the warm air up into the air, and it'll lead to heavy rain, usually marked by purple semicircles and triangles. We'll see that on the map. Weather maps also tell us where fronts are moving. So again, I mentioned this warm front is moving in this direction. This will be the warm front over here. This cold front is moving in this direction. Okay, the cold air is over here. We have an occluded front here. There's a stationary front. Okay, so the warm air will be on this side. The cold air will be on this side. as they move past each other. Cold front, it's moving this way, moving down. Okay, this map right here shows a lot of things. We want to look at, first of all, it's showing the barometric pressures. It's showing low pressure centers that usually indicates thunderstorms. High pressure center. The isobars are closer together. It would be windier here than it would be over here. Okay, you have a cold front here moving southeast. You have a warm front here moving north. Okay, the arrow here is showing the warm front moving north. This arrow is showing this cold front moving southeast. Okay, and again, the weather, you're going to have rain here. Could be thunderstorms, heavy thunderstorms for a very brief time. Here you might have rain over long periods of time, but not substantial rain. Okay, it wouldn't be severe storms. It would just be marked by, smaller storms. And the high pressure center here is usually indicative of milder weather. A low pressure system is less dense air mass that is usually wetter and warmer than the surrounding air. In general, areas that experience high atmospheric pressure also experience fair weather. So higher pressure in the center, so the air is moving out, it's moving in a clockwise direction. Okay. Low pressure systems can cause formations of clouds and storms, and the pressure is low in the center, so the air is forcing inward and it's going counterclockwise. We want to talk about weather station models today. That's how meteorologists kind of show their data that has been collected to predict the weather in the future. The data is represented in a station model, which is comprised of symbols that stand for different things. And we're going to look at temperature, dew point, precipitation, air pressure, cloud cover, wind speed, and direction. Okay. So here's what your weather station model looks like. Here, the cloud cover, sky cover. It's usually in eighths. They'll tell you if it's half covered, 3/4 covered, 7/8 covered. In this case, completely clear sky. This is the direction of the wind, and this is the wind. Okay, how fast? This is in knots usually 10 knots and 5 knots. But sometimes you'll have a situation where they indicate that these lines are greater, representing a greater value, like this could be 20 and this could be 10. They would say that specifically on the map. Air pressure, okay, sea level pressure. And then your trend, if it's dropping, it'll give you this. This is the symbol for dropping. Okay, and there's a chart that goes over all of the symbols. Your dew point, your actual temperature, and then your precipitation or other weather. Like you could have haze here or fog. You could have snow. You could have sleet. There's different symbols for all of those things. Once you have collected data from all of your station models, you can put them together and form a weather map. Isobars connect points of equal pressure, closely spaced indicate increased wind speed. Widely spaced, you have calmer wind, and closed circles are areas of high or low pressure. Isotherms are areas of equal temperature. So you have an area of a temperature map here. Okay. What if I said, gave you this map and asked you to identify a city that was in, say, the 50 to 60 degree range? On this map would be this color, right? Somewhere in there. So any city that would fall in here, possibly Little Rock, okay? Wichita Falls, Texas. Any city in Virginia, okay? Southern West Virginia, like Del Barton, West Virginia. All of Kentucky. You could give me Louisville, Kentucky. All right. This map right here, a lot of stuff going on here. It shows you the pressures, showing you the low and high pressure centers. Okay. You can tell me the wind from this. It's going to be windier here than it would be over here. Okay. There are a few weather instruments that I want to review with you that we've already gone over. Barometer measures air pressure. Psychrometer measures relative humidity. We've seen this in the dew point lecture. Air hygrometer also measures humidity. Rain gauge It's a lot of fun to have a rain gauge and see how much it's raining, but this just measures your liquid precipitation. Thermometers measure temperature. Anemometers measure wind speed. They can also indicate the direction. They will, but what it's measuring is the wind speed. And a wind vane measures simply the direction. So when you have at the helicopter launch pad, they're showing the helicopter pilot which way the wind's going. These instruments are typically conditions in the lower atmosphere, a radiosome, which is a weather balloon, okay, and it's sent up and will take measurements from the atmosphere, the lower part of the atmosphere, and send it back. These were kind of expensive, so they try to retrieve them. Okay, and satellites can be used to determine weather conditions in the upper atmosphere. I will tell you that if you're interested in science, we do have a new branch of the military called the Space Force. And they are, and I don't know if you know this, in December of 2019, the Space Force was created. A lot of people don't even really know that it's a real thing because there was a show on Netflix, I think, called Space Force. So with Steve Carell. If you're interested in satellites, they need satellite drivers, they need researchers, they need meteorologists. There are a lot of different career fields that they need in the Space Force. So it's something to consider if you have thought about the military and you want to do something new and innovative. There's definitely a lot of really cool jobs out there right now. And it's only been, the Space Force just had its birthday about a week and a half ago. So it was the very, very end of 2019 that it was created. So if you're interested in this at all, talk with me and you know, I can get you some more information. But some of the jobs are pretty cool that are offered. Okay, we have a map here. What's this map showing? We have a stationary front, cold front, another cold front, a warm front. You have precipitation, right? Your low pressure centers, which indicate that there will be precipitation. High pressure centers, fair weather. All of your station models, they indicate the direction of the wind. Winds going to the south, winds going to the north. Okay, you have about 10 knots as the wind speed. No cloud cover here. Okay, it's partially cloudy here. Okay, complete cloud cover here. So there's a lot that you can tell from this map. It's windier here or here than it is from here to here. All right. That's it for the lecture on weather forecasting. Tomorrow we have a web quest that we'll get started on that'll take Thursday and Friday to complete. I will still need you to log into Google Classroom, into the Google Meet, and we'll stay in the Google Meet through the duration of the period. I'll talk a little bit. I'll have some video clips to show you Thursday and Friday. But just make sure that you're there so that we can discuss this web quest. And if you have any problems along the way, I'm able to help you with it at that time. Okay? So I'll see you on Thursday. I hope you have a great day, everyone. Bye-bye.